Welcome to e-learning session. Myself Santanu Pathak, lecturer in food processing technology. In this session, we will discuss about unit operation of chemical engineering 1, unit 2, and in this particular session, we will discuss about second law of thermodynamics. Till now, we have discussed about the different thermodynamic properties, thermodynamic terminologies, and zeroth law of thermodynamics, first law of thermodynamics. And we have got the idea about enthalpy, PV work done, different type of thermodynamic process, etc. Now, after discussing the first law of thermodynamics, we have got few doubts. That means few things are there which is not cleared by first law of thermodynamics. What are those points? Number one, first law does not provide a clear idea about the direction or of absorption or evaluation of heat. That means direction of heat flow is not clear in first law of thermodynamics. Number two, the informations provided by the first law of thermodynamics are not enough to predict the spontaneity or feasibility of a process. That means first law of thermodynamics will not indicate us whether the reaction is feasible or not feasible. And along with that, first law of thermodynamics cannot guide us about the extent of conversion of energy. First law of thermodynamics is saying that energy conversion will be there, but up to which extent, that is not clear. So automatically some new law has to be introduced. That is nothing but second law of thermodynamics. The second law of thermodynamics states that any spontaneously occurring process will always lead to an escalation in the entropy of the universe. In simple words, the law explains that an isolated system's entropy will never decrease over time. Gradually, we will discuss these things. First of all, we will go for the different statements of this law. Number one, there are mainly two statements. Number one, Kelvin Planck statement. Number two, Clausius statement. Now, first of all, we will discuss about the statements. Kelvin Planck statement: it is impossible for a heat engine to produce a network in complete cycle if it exchanges heat only with bodies at a single fixed temperature. That means it is impossible to construct a heat engine which can operate at a single temperature. So first one, the C T1 hot temperature, and there is no other temperature. That means we are constructing a heat engine which is operating at a single temperature, which is impossible. So to operate a heat engine, we must have two temperatures and there should be a gradient. That means T1 and T2 should not be same. So if it is like that, then we can construct a heat engine. So this is the Kelvin Planck statement. Number two, that is Clausius statement. What is the statement? It is impossible to construct a device operating in a cycle that can transfer heat from a colder body to warmer without consuming any work. In other words, unless the compressor is driven by external source, the refrigerator won't be able to operate. That means it is very clear that if we want to transfer heat from colder body to hotter body, there must be some external work. Otherwise, it is not possible. Again, in this picture, we can see it clearly. T1 hot, T2 cold. So without having any work, it is impossible to transfer heat from T2 to T1, and T1 to T2, that is possible. Okay, so these are the two statements, and I think the statements should be remembered very carefully, because statements are statement, so you should not introduce your own word here. Now the question is there, what is spontaneous and non-spontaneous process. Spontaneous process means under certain conditions, some reactions, maybe physical or chemical reaction, which can be conducted by itself, system itself. There is no requirement for external help or external energy. Suppose you throw a stone from the top of a mountain. What will happen? Automatically it will come down. That means that is a spontaneous reaction. But if you want to send the stone from the bottom of the hill to the upper portion, you need to apply force. That is non-spontaneous reaction. Clear? Sometime to start a reaction or to start a process, some external energy is required just to start the process. Once the process is started, after that the external force is not at all required. That type of example of that type of process, that is whenever you are burning coal in presence of oxygen, so initially you need to apply heat. So once the coal caught the fire, after that there is no requirement of external force or external energy. It will continue the ignition process. So until and unless entire conversation is over, it will continue. So that is a spontaneous process, but to start up the reaction, some external energy is required. Okay, evaporation of water, it occurs automatically. So in that case, there is no requirement for any external force. Now the question arises here: what are the driving force for a spontaneous process? Why the process is spontaneous? There are two factors. Number one, lowering of lowering of enthalpy. Number two, increase in entropy. So these are the two factors, energy factors, as I say, which are important for a for determining a process as spontaneous process. Now I will elaborate few examples to understand this particular process. Suppose you have taken considered a system. Suppose you have taken or you have considered a system where there is no change in enthalpy, but entropy increases. So what will happen? Entropy increase means it is a spontaneous process. Correct? Now second one, constant enthalpy but lowering of entropy. What will happen? Lowering of entropy means the process is non-spontaneous. So you have to apply some external force. Number three, constant entropy but lowering of enthalpy. What will happen? Again, it is lowering the energy enthalpy. That means that is spontaneous process. Number four, constant randomness means constant entropy and increase in enthalpy. What will happen? That will be a non-spontaneous process. Lowering of energy and increase in entropy. What will happen? Lowering of energy and increase in entropy. So obviously this is a spontaneous process. Number six, increase in energy and lowering in entropy. What will happen? Increase in energy and lowering entropy. That means obviously that is a non-spontaneous process. Now increase of energy and increase of disorderness means increase of enthalpy as well as increase of entropy. What will happen? Now we have to take the magnitude of the value. Okay, then we have to decide whether it is spontaneous or non-spontaneous. Same for lowering of energy and decrease in disorderness. Again, we need to gather the data, how much energy is changing, how much entropy is changing. Then we need to calculate. If it is negative, then that means that reaction is spontaneous. So this is all about the spontaneous and non-spontaneous process, and we have already discussed in detail what is the driving force for the spontaneous process. Now The course already we have discussed about enthalpy. Now we will discuss about the entropy. What is entropy? Basically, entropy means chaosness of a system. Chaosness means when the randomness of the molecule will increase, disorderness of the system is increased. So that is called entropy. Entropy, the measure of the system's thermal energy per unit temperature that is unavailable for doing useful work, because work is obtained from the ordered molecular motion. The amount of entropy is also a measure of molecular disorder, randomness of a system. The concept of entropy provides deep insight into the direction of spontaneous change for many everyday phenomena. Already we have discussed these things. Now, entropy is a property which is dependent upon mass. So that is extensive property. And but now we will discuss about the type of function, whether it is state function or path function. So before considering it a state function or path function, we have to know little bit about the mathematical form of entropy. Entropy can be defined as del S equals to Q reversible divided by T. T means temperature in Kelvin, Q means heat absorbed by the system. Now, if we consider an infinitesimal small change, that is dq, then ds will be del q reversible divided by t. That del q is not a perfect differential. Then it cannot be integrated properly. So what will happen? Integration state 1 to state 2 ds equals to integration state 1 to state 2 del q reversible by t. That means after integration what will happen? S2 minus S1 equals to 1 by t integration 1 to 2 dq reversible by t. That means we can write the equation, that is del S equals to q reversible by t. Entropy of a system cannot be measured at any time. Only change of entropy can be measured. Okay, dq is a path function, but dq divided by t, that is a state function. So entropy is nothing but a state function. That means it is independent of the path. It only depends upon the initial and the final stage. Entropy of a spontaneous process is always increasing. That means we can write del S inverse is greater than 0. At absolute, one thing we have to keep in our mind, at absolute temperature, absolute zero temperature, for a pure and perfect crystal, entropy is 0. That can be derived from third law of thermodynamics. This is only for your information. In our syllabus, third law of thermodynamics is not there. What is the unit of entropy? Unit of entropy, that means q by t. Q means calorie, t means Kelvin. So a serious unit will be calorie per Kelvin, or SI unit will be joule per Kelvin. Okay, already I have discussed this thing. Cyclic integration del q reversible by t equals to 0. This is a state function. Del S equals to S2 minus S1. We can write this is already. We have discussed this thing. This gives the direction of spontaneous change. For isolated system, definitely we can write del S greater than 0. That means spontaneous, a reversible process. Del S equals to 0. That means reversible process. Del S less than 0. That is impossible. Entropy cannot be negative. Okay. Now we will discuss little bit about the change of entropy for several systems. For a chemical reaction, what will happen? Del S equals to S2 minus S1. S2 minus S1 means summation of entropy for the product minus summation of entropy for the reactant molecule. For cyclic process, what will happen? Del S equals to S2 minus S1, and the cyclic process means the initial state and the final state is same. That means S2 equals to S1. That means S2 minus S1 equals to 0. So change of entropy del S will be 0. But that means we can say for a cyclic process there is no change in entropy. Reversible adiabatic process, what will happen? Reversible adiabatic process means dq equals to 0. That means heat cannot be transferred from system to surroundings or vice versa. That means ds equals to dq by t, d equals to 0. That means change of entropy, that will be 0. So in this way we can say change of entropy for different type of processes. Now we will discuss about the entropy and second law of thermodynamics. All spontaneous reactions are irreversible and that too a certain direction. That means all reactions are irreversible and in a certain direction. So for all natural and spontaneous process, the change of entropy of the system and surroundings is gradually increasing. That means positive. So we can write del S system plus del S surroundings greater than 0. Entropy of universe is gradually increasing and approaching towards a maximum value. Del S total equals to, we can write del S system plus del S surroundings, that is nothing but del S universe. For a spontaneous reaction, again I am saying del S universe, that means change in entropy for universe, it should be greater than 0. For a reversible process, what will happen? Del S universe equals to del S system, means change of entropy in the system plus change of entropy in the surroundings, and that will be 0. Why? Reversible process means there is no change in internal energy. There is, so entropy change will be 0. Hence we can say del S system equals to minus del S surroundings. So already we have discussed these things. For irreversible process, already we have discussed these things. Now, before going to the next topic, again I have summarized the thing for the entropy. For spontaneous process, del S universe equals to del S system plus del S surroundings, it should be greater than 0. Number 2, for reversible process, del S universe equals to del S system plus del S surroundings, that will be 0. For a system in equilibrium, we can write del S universe equals to del S system plus del S surroundings equals to 0. So these are the basic concept of second law of thermodynamics and entropy. Now here I have placed a question answer session. Uh, what is the difference between heat engine and work engine? This is a conceptual question, and I hope all of you will be able to answer these questions. So here answer is written, and I am not going to discuss these things in this session. I am letting it to you. Please try by yourself, and if there is any doubt, feel free to communicate me. Thank you. For any query, please email me at sp.fpt.arm@wbscte.ac.in.